In the previous section, we encountered a big difference between solving inequalities and solving equations. And we noticed that whenever in solving our inequality, if we ever divided by a negative number or multiplied by a negative number, we actually needed to flip the sign of the inequality to remain the statement to remain true. So let's take a look at several more examples of these because we really want to get this down before moving on, because we'll actually be using it extensively when solving equations, moving on into solving compound equations, and looking at applications. So we need to get this before we move on. So we have minus 2x is less than 10. We simply solve this by isolating our variable x, by dividing both sides by a negative 2, which these two cancel. This gives us a positive x, which is less than. Our less than sign needs to be flipped because we're dividing by a minus 2. Our less than becomes a greater than. So we have x is greater than minus 5. Now notice we can check this by plugging in any number, any value for x that's greater than minus 5 into our original inequality, and it should hold true. So let's go ahead and prove one of these. We have minus 2. We need to pick in for x a number greater than minus 5. Actually 0 is a nice round number that's greater than minus 5. So let's plug in 0 for x. We have less than 10. Minus 2 times 0 is 0. 0 is definitely less than 10, which makes this statement true, and that means our interval is actually a valid solution for our inequality. All right, so always remember that when we're dividing or either dividing or multiplying by a negative number, we need to flip the sign for the inequality to remain true. All right, let's look at a few more of these. Let's say we have minus 1 over 9 times x is greater than or equal to minus 3. We want to solve this for x, so we multiply both sides by negative 9 over 1, which is just the reciprocal of negative 1 over 9. This term cancels, so we have x on the left-hand side. We're multiplying by a negative number, so we need to flip our inequality sign. Our greater than or equal sign becomes less than or equal to. Minus 9 times a minus 3 is a positive 27. And again, we can check that this is true by picking out either a number less than 27, or we can pick 27 because x can be equal to 27. It's included in our interval solution. And we can plug that number into the original equation, and it should remain true. So I'll leave that. That's a good check for you once we get done with a few more examples. Let's do some more practice. Let's say we have minus x is greater than 20. Now this one's simple. We actually just flip the signs on each side, but let's actually go through the process of it. We can either multiply or divide by minus 1 here, which in turn cancels these negative signs. So we have a positive x on the left-hand side. We had our inequality solved for a minus x, but we don't want to know what the opposite of x is. We want to know what x is. So we need to flip our sign from greater than to less than since we divided by a negative. And on the right-hand side, we have minus 20. All right, so essentially we went from minus x is greater than 20 to plus x is less than negative 20. We just flip the signs. But whenever we're doing so, we need to flip the inequality notation. Let's look at the next one. We have minus 2 over 5 times x is less than 11. We simply solve this by isolating our x, by multiplying by the reciprocal of the coefficient of x. So minus 5 over 2 is the reciprocal of minus 2 over 5. This term cancels, so we have x is greater than, we're flipping the inequality sign, minus 5 over 2 times a positive 11 is minus 55 over 2, and that's our interval solution. All right, it doesn't include minus 55 over 2. It includes any number greater than minus 55 over 2. We can check that by plugging into our original inequality. Let's do a couple more. We have minus 7x is less than or equal to minus 49. Okay, so let's go ahead and isolate our variable by dividing both sides by a minus 7. These two terms cancel, leaving x on the left-hand side. We're going to flip our sign from less than or equal to greater than or equal to. These two signs cancel. 49 over 7 is the same thing as 7. And that's our interval solution. All right, not a whole lot to these. We just need to get used to recognizing it when we're dividing by a negative or multiplying by a negative. We need to flip the inequality sign. So let's go ahead and squeeze in one more down here. Let's say we have minus 11x. Minus 11x is less than 121. Let's isolate our variable by dividing by the coefficient. So we have a minus 11 divided by a minus 11 on the other side as well. These two terms cancel. So we have x. We're flipping the inequality sign. So we have greater than. Less than becomes greater than. 121 divided by minus 11 is just minus 11. And that's our interval of our solutions. Now remember, when we're dealing with inequalities, the very first difference we talked about, as opposed to linear equations, is that the solution to a linear inequality is a set, an interval, if you will, of values. In this case, it's the set of all real numbers x such that x is greater than minus 11, where linear equations, the solution tends to be just a single value. Here it's several values. So I wanted to do a video on this just to nail home that whenever we multiply or divide by a negative number, we have to flip the inequality sign. Less than becomes greater than or equal to becomes less than or equal to, and so on and so forth. And I'll leave these as good checks to plug in an appropriate number into our original inequality to make sure that it holds true, which we proved in the previous section, and that's why we flip the signs. So we need to get comfortable with this before moving on to actually solving complex linear inequalities and doing applications. So I'll see you in the next video.